confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm. Thank you. So, hello, good evening to all of you, and welcome to Baiju's Exam Prep IAS. Welcome to another session of climatology, where today we shall be proceeding ahead with the portions of Indian monsoon. Now, yesterday, while we were discussing about the factors influencing the Indian monsoon, we had till now discussed two of the important factors. Amongst the two factors that we discussed, one was the heating of the land. Now, once the land gets heated up, that creates a substantial low pressure, and that is a thermal low pressure. Nearby water bodies considerably tend to remain cooler. And as the nearby water bodies tend to remain cooler, they form a comparative high pressure. So the winds from the water tends to blow over to the Indian subcontinent or the Indian mainland. Now, these winds are moisture bearing. These winds carry a lot of moisture and they bring substantial amount of rainfall when they hit the land. So that is the aspect which we can consider, that it brings rainfall over the Indian subcontinent. But here, heating of the land is accompanied by the shifting of the ITCZ, where from the month of April itself, the ITCZ starts transitioning in the north. It starts slowly and steadily advancing over the northern portion and over the entirety of the Indian subcontinent. By the month of June, the ITCZ truly and completely establishes itself over the northern part of Indian subcontinent, sometimes passing very close to the region of the Himalayas, sometimes passing through the region of the Tibetan highlands also. The ITCZ does shift north. Now, the shift of the ITCZ is not a kind of a customary thing. It has got a significant amount of influence along with that. And when we say the shift of the ITCZ to the north, basically that means that the trade winds from the southern hemisphere, they tend to get attracted towards the Indian subcontinent. Now, these trade winds, basically, while they reach the Indian subcontinent, they have a direction of southwest to northeast. That is the direction associated with these trade winds. Now, as these trade winds move in a direction of southwest to northeast, that is why the rains that they bring, the monsoon rains that they bring, they are also known as southwest monsoon. Having said that, it is not as if the trade winds, by the time that they reach the Indian coastline, they will be able to bring rainfall. No. Onset of monsoon is a terminology which is used in order to define when you have had a continuous amount of rainfall observed over the region of Kerala, the Kerala coastline, for some considerable period. And it is the measurement of the rainfall that this much amount of rainfall should have occurred. Along with that, you should have significant low pressure systems developed over the Indian subcontinent, availability of wind movement, and then only we declare the onset. So basically, the southwest trade winds reaching the Indian subcontinent does not mark the onset of rains. The winds do reach the Indian coastline almost up till the region of the Indian coastline, but still, for a considerable period of time, India does not receive rainfall. Because there is one factor which does not allow the movement of winds to happen over India. And as long as that factor prevails, as long as that factor does exist, India does not receive rainfall. India does not experience that much amount of rains. So, what is that factor? That factor is what is the subtropical westerly jet stream. Now, we have all discussed about the subtropical westerly jet stream yesterday also, that amongst the four permanent jet streams. You have two of the polar jets and two of the subtropical westerly jets. The subtropical westerly jet stream that does flow into the region of the subtropics in general, basically around the transition of the Hadley and the Ferrel cell. Now, just to see if you have revised or not, could you let me know which of them is going to be more powerful, the subtropical jet stream or the polar jet stream? Which is going to be more powerful? Very good. It is going to be the polar jet. Subtropical westerly jet is not that powerful or not that strong enough. Now, we do know something about the subtropical westerly jet stream, and that is the fact. So, first of all, let us draw the equator. Let's suppose this is the equator. Now, during the winter months, all the pressure belts will shift slightly to the south because it is summer in the southern hemisphere. So ITCZ will shift to the south. So subtropical high pressure belt will also shift to the south. So all the pressure belts will shift to the south. Fair enough. The subtropical westerly jet stream, that also does shift to the south. Now here, let us assume when we talk about the subtropical westerly jet stream, it is generally to be found in the region around 30-degree latitude. Now, when we say that it shifts to the south, we are talking somewhere in the zone of around roughly 20, 25 degree, 23 degree, roughly in that area is where the subtropical westerly jet stream prevails during the winter months. So that means this jet stream is going to have, during the winters, a movement somewhat like this. Now, we have seen that the subtropical westerly jet has got a distinct northern branch and then a distinct southern branch. Fair enough. We have seen this portion, that this is your jet stream. It has got a distinct northern branch and a distinct southern branch. Any issue up till now? Northern branch, and this will be southern branch. As long as the southern branch of the jet streams, they do prevail over the Indian subcontinent, they won't allow for the movement of winds underneath them. So even the moist winds, the moisture bearing winds, which have reached the Indian coastline, they won't bring rainfall. But till now, we are still talking about the winter months, so moist winds have not reached the Indian subcontinent. Now let's say the summer season has come in. The summer season has come in, as in from the month of April, etc. The land has started getting heated up. Regions such as Rajasthan, Madhya Pradesh, Delhi, Punjab, even Uttar Pradesh, Bihar, they already start exhibiting temperatures in the range close to around 35 to 40 degrees Celsius by the time of end of April and the initial portion of May. So the ITCZ starts shifting to the north. Now, if the ITCZ will shift to the north, will I be correct to conclude that accordingly all the other pressure systems will also be shifting to the north with the northward shift of the ITCZ? Isn't it? So if all the pressure systems are shifting to the north, the jet stream will also start shifting to the north, isn't it? Because jet streams, they are formed at these transition zones between the pressure cells. So they will also start shifting to the north. Now, here you will observe that as these pressure cells they shift to the north, the jet stream shifts to the north, but it is not a typical shift associated. By the time of end April or in the first weeks of May, when the ITCZ already comes over to the Indian land, here the jet streams overall, they indicate a slight shift in the northward direction. Now, would I be correct in concluding that if the remainder portion of the jet stream will start shifting to the north, that would lead to the enhancement or more powerful northern branch? The northern branch will now get more supply of air because the entire jet stream has started shifting to the north. So if northern branch will start getting more supply of air, that would have to come from somewhere. So that would mean that the southern branch starts getting weaker. Okay, till now? Till now, is it understandable? That northern branch starts becoming stronger as the remaining portion of the jet stream starts moving northwards, the northern branch starts getting stronger. The southern branch, on the other hand, is not as strong, is not going to be anywhere that strong. It starts to weaken. It starts becoming weaker and weaker. Right? But as long as the southern branch of the jet stream prevails, the monsoon winds won't come to India. By this point of time, by the end of May, monsoon winds or the moist winds would have already reached the Indian coastline. They would have reached this portion. But they don't cause rainfall. Why? Because of the obstruction offered by the southern branch of the jet stream. Now, immediately you will have a question that this southern branch of jet stream that you are indicating in the map, that is somewhere in the region of Madhya Pradesh, Chhattisgarh, West Bengal, Jharkhand. Now, if there is the jet stream in West Bengal, Chhattisgarh, Jharkhand, why can't we have rainfall in Kerala, which is very far away? The reason is very simple, and that is the traffic signal analogy. For jet stream understanding, traffic signal analogy. What is the traffic signal analogy? That is basically, let's suppose you are on a road moving and you encounter a traffic. Now that traffic might be caused because of the signal which turns red. The signal has turned red and there are cars which are lined up for many kilometers, maybe 4 kilometers. Now, when you drive your vehicle, you will park your car somewhere here. You will wait. Regardless of the fact that the jam created is 4 kilometers away from you, but does not mean you will be able to reach the traffic signal on your own immediately, unless and until you are one of those traffic ninjas on a two-wheeler who basically can navigate through endless amount of vehicles on the road. You will be left around 4 kilometers away. So here you can have the same question, that the jam is created because of the signal 4 kilometers away. Why should I be stuck here? I should be moving. But how can you move? There are other vehicles on the road. Similarly, when you have the jet stream somewhere in the central portion of the country, that creates a kind of a blockage for the movement of the wind systems. So the entire wind system that tends to remain stagnant, because we have seen that these jet streams don't allow the air to mix. Air from one portion is not allowed to go to the air region of other portion, right? So is this portion understood, that why, as long as the southern branch of the jet stream is present, why is there going to be a substantial or a delay in the occurrence of rainfall? Is this portion clear? Right? That despite the fact that southern branch of the jet stream is somewhere in the central portion of the country, still you will not have rainfall even in Kerala because of the monsoons. You might have individual convectional rain in one district of, let's suppose, Palakkad, or one district of Cochin here or there. But you won't have the onset of monsoon to occur as long as the southern branch of jet stream is in existence. I hope this portion is clear. Now, the month of May progresses. By 20th, 21st of May, the land would have experienced temperatures ranging in certain areas in the north. The temperatures frequently touch 45, 46, 47 degrees Celsius. So the temperatures are very, very high temperatures. Now, when you have such very high, substantially high amount of temperature, the ITCZ further moves north. ITCZ moving north would mean what? The pressure belts will also shift north. The jet stream will also start shifting further northwards. So this jet stream that you are seeing here, this would shift further to the north. Now, can I say, as there is this more accelerated shift to the northern branch almost gains the entirety of this jet stream wind movement, almost the entirety. And over the Indian subcontinent, now the entire region is getting heated up. So the difference in temperature is not very prominent anymore. It is, after all, the difference in temperature which leads to the occurrence of the jet stream. But when the entire landmass is superbly heated up, significantly heated up, you don't have that difference of temperature anymore in the upper air. So the southern branch weakens and weakens. That is when, by the time of mid-May, you will find that the Indian Meteorological Department, the SkyMet, the private agency, and all the various climatologists, they start making predictions that this time the onset of monsoon will be on 5th of June. This time the onset is advanced. It can happen in the last week of May. This time the onset will be on 1st of June. What is that prediction based upon? Is it that all of them together went to an astrologer, asked the astrologer, tell me what is the auspicious date when the monsoon should arrive, so that is what they will declare? No. It is basically that northward shift. And it is that prediction that when is it that the southern branch will disappear. Because one fine day, as this northward shift of the entire jet stream continues to happen, one fine day, the southern branch will suddenly disappear. It will weaken, weaken, and weaken till it suddenly disappears. Now, again, bringing you back to the traffic analogy. You have all been stuck in traffic in various different times. Let's suppose, recall a moment when you are stuck in a very significant amount of traffic for almost half an hour, and suddenly the light goes green, or somebody gives the green light The traffic policeman comes and says that now you can move. What happens? Do people start moving slowly? That, okay, now we have gained the green light, let's move slowly, let's carry on with our lives? No. They move almost with a vengeance. That now I will move maybe at 120 kilometer per hour. I will make up for the lost time. Isn't it? I hope you are able to identify what I'm trying to get at. There is a kind of a rush. Suddenly, from anywhere, everywhere, people would want to get out. Similarly, this jet stream basically was an obstruction of various different types of air particles, various different air parcels. Now that jet stream has suddenly gone away. What will you have? The air will start moving simultaneously at various different levels now. There was obstruction in the upper atmosphere, in the upper troposphere, in the mid troposphere, and in the lower troposphere. Now that will create that rush of winds. Now, this rush of winds created inland means there will be vacancy created, and these winds which have been waiting over the Arabian Sea, they will first of all hit the Kerala coastline. When they will hit the Kerala coastline, generally, they hit the Kerala coastline either in the last week of May, around 27th, 28th of May, or 1st of June, which is the average time, or sometimes it is delayed to 4th or 5th of June. But in those 10 days duration is when they will definitely hit the Kerala coastline. Rapid convection will happen as soon as these moist winds come, because understand, these moist winds are coming all the way from the region of the southern hemisphere. And in their entire movement, they have been moving over water body. So they have been moving over the region of the water body. So one characteristic that you could definitely know about these winds is that they will be moisture laden, heavily rich in moisture. Now these moisture laden winds basically here, they will hit the Kerala coastline, cause for a substantial duration, a significant amount of rainfall. That is what is regarded as the onset of monsoon. So again, a quick recap. When we talk about the subtropical westerly jet stream, this subtropical westerly jet stream, as it moves over to the region around 30°, 25°, it gets divided into a distinct northern and a southern branch. The southern branch moves over to from the central portion of the Indian subcontinent. Now, when the heating of the land from the end April is initiated, that is when the ITCZ starts coming over to the Indian subcontinent. Now, as this ITCZ starts coming over to the Indian subcontinent, that is when all the other pressure belts will also start shifting to the north. The northward march or the northward shift of the other pressure belts would also end up meaning a migration of the jet stream, the northward movement of the jet stream. Now, as the entirety of the jet stream starts moving northwards, we can say that the northern branch keeps on getting stronger, the southern branch keeps on weakening. But as long as a southern branch of the jet stream is present, there won't be occurrence of monsoon, or the onset of monsoon won't happen, because they will serve as a blockage. They will serve as a blockage for the wind systems in the entire region. And whenever you get confused that why over the central portion of India, if there is the presence of that southern branch, why will there not be any rainfall in, let's suppose, Kerala, always recall that traffic signal analogy. That regardless of wherever the jam is, you have to wait unless the rest of the vehicles get cleared. But once the signal goes green, and in this case, what is that green signal? The sudden disappearance of the southern branch. Whenever you have that sudden disappearance of the southern branch, immediately there will be substantial and significant amount of rush of winds in the upper atmosphere, in the lower surface level as well. That brings into play multiple convections, and then that leads to causation of prolonged rainfall in Kerala. That is when we declare that onset of monsoon has happened. It will take around a month for this monsoon system to cover the rest of the country, more than a month. It is not as if Punjab will also receive rainfall on the same day. Punjab will receive rainfall may in end June or maybe a first week of July, but Kerala will start receiving rains. Is this portion understood? Perfect. Why don't they hit Somalia or Kenya in Africa? I've shown you the wind direction. They will bring some amount of rainfall in Somalia, Kenya also. It is these winds which will bring some amount of rainfall in those areas, which lowers the temperature or in those areas, which makes those areas a bit cooler. Okay. Just to tell you the why southern branch don't shift. Southern branch doesn't shift north because of one of the largest physical barriers that planet Earth has got to offer. And that is in the form of the Himalayan mountains and the Tibetan highlands. This is the largest physical barrier that planet Earth offers. Jet streams. See, understand it in this way. These are the mountain systems. It is because of this obstruction that jet streams have bifurcated into two. Now, as the northern portion is shifting, let's suppose the northern portion is shifting, you cannot expect the southern branch to ride over the mountains and then flow. Because if the southern branch could have risen over the mountains, jet streams would never have bifurcated in the first place. Jet streams would have simply climbed over the mountains and moved. So their inability to climb over the mountains or flow over the mountain tops means that this southern branch remains where it is. The rest of the jet stream moves or migrates north. There is strengthening of the northern branch. The southern branch continues to weaken. Is that understood? Right? To form rain, there has to be condensation. But here it is not happening. So, Bhimre, what is actually happening is that you have these moist winds, very rich in moisture. The amount of moisture that they carry, that is very, very high. So, this high amount of moisture that they bring, now that heavy amount of moisture basically brings about substantial amount of on hitting the land, this moist wind, because the land has been heated up, the winds will rise up. They will face the barrier in the form of Western Ghats. There will be orographic, convectional rainfall, where the winds will then rise up, lead to condensation, and eventually cause rainfall. So that is the assumed part, which I'm not specifying here. What is the confusion, Prem Kumar? Please let me know. So, overall, I hope that you understand the aspect of the onset of the monsoon. Yes, Ankush, that is correct. Now, here, when we talk about it, so subtropical westerly jet streams are the jet streams which tend to develop over the region of the subtropical high pressure belt during northern and the southern branch. With the onset of summer season, as the ITCZ shifts north, the southern branch of the jet stream, that starts to weaken. And that is when, as soon as the disappearance of the southern branch happens, that is when we say that there has been onset of monsoon. Okay, I hope that is understood. How and why the southern stream of jet stream disappear? Prem, are we able to fathom why the jet streams will will shift north in the first place? Do we have an understanding of the fact that why these jet streams will be shifting to the north in the first place? Akshay, I missed on that part. Which part? Okay. So, Prem, kindly take a look at the recorded sessions for yesterday, where we discussed about the jet streams, the subtropical jet streams, where we discussed about this subtropical westerly jet stream, its northern and the southern branch. So that is where you will understand when you observe the formation of, I guess you basically would have missed that particular portion where it was discussed about the formation of the jet stream, where these jet streams are present. So as the ITCZ shifts to the north, the entire pressure systems, they shift to the north. With the shift of the pressure systems, the jet streams, which are intertwined to those pressure systems, pressure cells basically, these jet streams, they also start transitioning northwards. So that is when, as these jet streams, they shift to the north, there will be the northern branch will get stronger, the southern branch will get weaker. So take a look at the recording, you will understand in a better way. Now we come to, let's suppose, the distribution of rainfall. Is this the only reason the monsoon can cause delay in the Indian subcontinent? Yes, the onset, when it is delayed, it is because of this reason. Sushmit, splitting of jet stream happens because of physical divergence or due to the differential heating of the land, as jet stream is high in the atmosphere. Jet stream, there is a physical barrier factor also that is very significant. That physical barrier, basically, it is not only a physical barrier but a region of very cold air. So that provides a difference in temperature in various different parts along with that. But primarily, it is a combination of both. You cannot say that it is not because of the physical barrier of the Himalayas. This means, sir, now the southern subtropical westerlies are trafficked now. Right now, if you are getting at the present situation, Bhimare, basically, right now, you again have the jet stream, the southern branch of the jet stream, which is established over the Indian subcontinent, which is well and truly established over the Indian subcontinent as of now. Okay, the southern branch is there over the central portion. Okay, now coming to the distribution of rainfall and the occurrence of rainfall. So I'll take the help of this particular map. Now, the monsoon winds have come over here. They have hit the Kerala coastline. Meanwhile, the winds have also reached here. After getting deflected from the Arakan Yoma, Pegu Yoma, Tanasare mountain ranges, the winds have also come into this region. Now, first of all, Kerala would receive rainfall. Andaman would also start receiving rainfall. Lakshadweep would also start receiving rainfall. But Kerala would receive rainfall first. After this, these winds, they would enter from here. And they would cause rainfall over Bangladesh. Then these winds would hit the Himalayas. Now, the Himalayas here, they are very tall. They are very high in this region. It is not the case that Shivaliks are very predominant, so lower ranges, high ranges. So here, two things will happen. The first thing that will happen is that immediately at the foothills, you will start receiving substantial amount of rain at the foothills. Okay, that is the first thing. Second thing is that the winds would get split up. One portion would go into the eastern direction, into the northeastern states. There, this wind system will get trapped in between the hills, causing copious, a very high amount of rainfall in the northeastern states. The other portion will move in the eastern direction. Bihar, Jharkhand, Bengal, they will start experiencing easterlies, the easterly winds. These are moisture laden. They will bring a kind of a cooler advection because the ground temperature is already very high. They will lower down the temperature a bit. These are coming over from water bodies. And then they will cause rainfall. They will form cumulonimbus clouds in those areas and they will cause rainfall. Meanwhile, on the other side, that is in the region of the Indian subcontinent, the southern part of Indian subcontinent, here, these wind systems, they start traversing towards the north. They hit the Mumbai coastline in a week after causing rainfall in Kerala. It takes almost a week for these wind systems to hit the Mumbai coastline. Now, here you will have the Vindhyas and the Satpuras, these mountain ranges. Now, one branch of the Arabian Sea branch of monsoon, or one segment of the Arabian Sea branch of monsoon, will enter through this pathway. They will reach the central portion, the Amarkantak region. This region would also receive rainfall. So simultaneously, central and eastern India starts receiving substantial amount of rain. Meanwhile, through the gaps which are present, Thal Ghat, Bhor Ghat gaps in the Western Ghat, the regions such as Nashik, Pune, they also start receiving rainfall in a time duration of 10 days, 20 days. It enters into the region here, western portion of Tamil Nadu, the Nilgiris, around the region of Uti, Mannar, the region of Bangalore, they will receive rainfall. Northeast is anyways going to start receiving very heavy amount of rainfall. And understand the thing with the northeastern states. There's a kind of a funnel shape created by these mountains. So as long as the wind system keeps on getting supplied, these wind systems will continue to cause rainfall in that area. Now, there is a third segment of this Arabian Sea branch of monsoon. And the third segment of Arabian Sea branch of monsoon starts moving northwards. As it starts to move northwards, it encounters the Aravalis. So the first obstruction that it encounters in the form of Aravalis is in southern Rajasthan around the region of Mount Abu. North Gujarat and southern Rajasthan receive rains. Then this wind, as it moves parallel to the Aravalis. So western Rajasthan doesn't receive rainfall. Meanwhile, this easterly wind coming from the region of Bay of Bengal, it will continue to drop moisture wherever convection happens or the low pressure centers are present. There will be convection, cumulonimbus cloud formation, thunder, lightning, and occurrence of rainfall. It will slowly and steadily advance over the Indian subcontinent. Hence the name, advancing monsoon. Now, these easterlies from Bay of Bengal, they will also hit the eastern portion of the Aravalis, the eastern Rajasthan. There they will cause rainfall. Then further north, the Bay of Bengal branch and the Arabian Sea branch, they meet. They meet together. They cause rainfall in the region around Delhi. But there, you don't have much of an orographic barrier. So, the winds, as soon as they cause that rainfall, let's suppose in a particular area, there is a substantial amount of low pressure. Moist winds are coming from this area. Moist winds, they also find that low pressure, get heated up, they rise. They cause very dense cloud formation, leading to very heavy rainfall in the process. Very, very heavy amount of rainfall is caused in the process. Now, this heavy amount of rainfall, what will it do? Can I say it will lower the temperature? Whichever region you are living in, remember the summer months. It would get very hot. The temperature would keep on increasing 40, 43, 44, 45 degrees Celsius. It becomes intolerable. And then there is a significant and a continued rainfall carried on for around a couple of months, 2 months, or not couple of months, couple of days. Let's suppose it rains quite heavily for the next 2 to 3 days. Temperature cools down, it temperature lowers. So when the temperature cools down, it becomes cooler. Can I say that this low pressure system will get diluted? Can I say that the now this low pressure system will get diluted? After causing rainfall? So now, after 3 to 4 days of this rain, temperature has lowered. So the winds, they march forward because there's a continuous supply of winds coming over. So the winds march forward. What is the destination of these winds? Where are these winds trying to get to? They are trying to move towards the ITCZ. That is the most powerful low pressure system, thermal low pressure system. So all of them are attracted towards that ITCZ. In the meanwhile, they get these low pressure cells which are formed across the entirety of the Indian subcontinent. Around 3 to 4 such low pressure cells are formed. Those are known as monsoon troughs. Low pressure cells formed over the Indian subcontinent due to heating, which attracts winds towards them and causes rains in the region. Again, I will repeat the entire concept of this monsoon trough. The strongest thermal low pressure is the ITCZ. Fair enough? All of us will agree to the fact that the strongest low pressure is the ITCZ. Let's take a help of another map. Let's take the help of this map. Now, let's suppose the ITCZ has shifted here. Now, if I ask you that ITCZ is the thermal low pressure. So across these ITCZs, more or less, we can agree that the temperature would be very high in these areas. That is why a thermal low pressure. But during the month of end May, early June or mid June, the temperature in Madhya Pradesh, around, let's suppose, in the region of Indore, Nagda, Ujjain, that area, will be very high. It will be around 42, 43 degrees Celsius. The temperature in the region of Bundelkhand will also be very high, right? Temperature, let's suppose, in Jharkhand, very high. Temperature in the eastern portion of Madhya Pradesh towards the Baghelkhand area and the Chindwara region, very high. Temperature in West Bengal, very high. So, can we agree on this point that even other than the ITCZ, the Indian subcontinent will indicate multiple regions of very high temperature? Can we agree to that? Any doubt in that? No? Good. So, despite the existence of the ITCZ in the northern part of the country, northern part of the subcontinent, sometimes this ITCZ even transitions over to the Tibetan highlands. But many parts of the country will experience very high temperature range. And understand, this might appear like a map to you, a small region where the ITCZ is, let's suppose, passing over. So in the map you see almost the central portion of entire UP, Bihar, etc. covered. But a low pressure region around, let's suppose, the foothills of Himalayas in UP, around the region of Katarnia Ghat, for example, that means you can have simultaneous low pressure developing over the region of Bundelkhand in UP, because they are hundreds of kilometers away. Similarly, if you have a low pressure cell over in the ITCZ, let's suppose, is passing through the region of Punjab, does not mean Rajasthan will be colder. Rajasthan also will be very hot. So, by this time in the late or in the month of June, mid June onwards, there are formations of multiple low pressure systems over the Indian subcontinent. Around 3 to 4 such very significant low pressure systems are formed. These low pressure systems, these are what are known as monsoon troughs. Understandable? Is this understood? Clear? Any doubt till now about the occurrence of monsoon trough, about the shift of the ITCZ, about the onset of monsoon, about the distribution of rainfall? Any doubt? Akash, I am confused how the winds stop at one place, like an example of the traffic jam. Basically, if let's suppose there is an obstruction offered by the winds, let's suppose the jet stream is moving here, the air mass in this region cannot mix because of the jet stream. And this jet stream is not a small city phenomena, this is a global phenomena. That means it is widespread. Now, if the air cannot move here, the air here cannot move either. There is a consistent forward motion of the air happening. So all that gets jammed up and it keeps on getting accumulated. Suddenly, when this will disappear, there will be that sudden motion. Krishika, like easterlies are present at higher latitudes. Easterlies are present at 90 to 60 degree latitudes, yes. But as you told, in Bihar, rainfall occurs due to the easterlies. So is it possible that westerlies and easterlies can occur at the same time? No. These are not the polar easterlies that I'm talking about, Krishika. Polar easterlies are present from 90 degree to 60 degree. This is basically, so will India at this point of time experience westerly winds? No, because the IT season in itself is here. So the northern trade winds will be present here. Westerlies will be present further to the north. These are the localized winds, local winds, the monsoon winds, which bend to the left here because of the divergence. They bend to the left here. So in this region, can we say that the winds are moving from east to west over West Bengal, Bihar? They are moving from east to west. Winds are oftentimes named after the direction that they originate. So in that localized region, that is why can we refer to them as easterlies? That is why we have referred to them as easterlies. These are not the permanent wind easterlies. These are the temporary or the local region easterlies that because of the divergence or after hitting the Himalayas as they are forced to diverge. Okay, it is not as if they randomly or they voluntarily choose that eastward, the east to west motion. They are hitting the Himalayas and then they are forced to diverge. And then there is that attraction towards the low pressure cells over the land area where these winds continue to get attracted. That is why these easterlies they bring rains. Okay. Sushmit, I hope that answers your question also that why the winds move to the left. So it is basically they are pushed to the left by hitting the Himalayas and the divergence caused. And secondly, they keep on getting attracted by these low pressure systems. Ankush, there are convectional storms created in monsoonal troughs. Yes, yes. And in southern India, Sushmit, what you are yesterday also I had told you, basically here these wind systems they get bifurcated, and then the Sri Lankan landmass also ends up channelizing the winds here. They move in this direction. Their destination is that low pressure. Then you have the entire mountain range, Arakan Yoma, Pegu Yoma, Tenasserim mountain ranges here. They basically transition these winds, and that is when the winds they hit or they enter the subcontinent from the side of Bangladesh. Dikshit, winds get trapped in Purvanchal. That's why Mosindram receives the highest rainfall. Absolutely correct. And Anjan, troughs can only be in central India near the ITCZ where they heat up the most. Perfect, yes. Wherever see, even these monsoonal troughs, I won't go into much of the detail, but then even these monsoonal troughs, depending upon the temperature on the landmass, these troughs, they have their own motion. Indian Meteorological Department's website at the end of the year presents you with the analysis. Sometimes, when the northern portion by the mid of June, by the end of June, does not receive rainfall, this entire low pressure system it transitions north. What do we mean that it transitions north? This entire low pressure system, these will be the low pressure areas. So, in these cases, the foothills of Himalayas will receive very heavy amount of rainfall, but the rest of the country, the winds won't be attracted to the rest of the country, so the rest of the country will remain drier. Then sometimes in the month of July, August, when the northern portion receives very heavy amount of rainfall, sometimes by that point of time, the southern part starts getting heated up. And that is when the troughs develop over here. This is when even this region will receive rain, this region will receive rain, this region will receive rain. The larger part of the country will receive rain, but the Himalayan foothills will comparatively stay dry. So this entire trough system in itself tends to also transition. Okay. So that is basically the onset of Indian monsoon. In a nutshell, all that you need to know is the basic fact. Heating of the land create, and listen to the next 4 to 5 minutes very carefully. Heating of the Indian landmass creates a very distinct low pressure cell. or low pressure center. Comparatively, the water bodies, they have the presence of a comparative high pressure where you have colder waters, right? Now, from this high pressure, the winds move over towards the region of that low pressure. They cause substantial amount of rains, right? They cause substantial amount of rains over the Indian subcontinent, over the Indian mainland, right? Along with that, you have the shift of the ITCZ that keeps on attracting winds, the southern trade winds. But these trade winds, which have carried moisture after their movement over the oceans, they still won't be able to bring substantial amount of rainfall. They won't be able to bring onset of monsoon because there's the subtropical westerly jet stream, the southern branch of subtropical westerly jet stream. The moment the southern branch of the subtropical westerly jet stream disappears, that is when the onset of monsoon happens. Is that clear? Is Punjab northwest region also for monsoon trough? Yes, Bimare, correct. There are few of you whose progress in terms of understanding of the concepts has been very tremendous and very encouraging to see. Few of you basically from the portion of geomorphology, the mind has simply exploded and climatology is simply not fitting in. That is also very apparent. But few of you from the initial portions of climatology, you have made a tremendous amount of progress. So I like those kind of things where you are able to predict, you are able to formulate that what impact will this lead to. Uh, do easterlies stop at Aravallis and empty all its moisture or move further? So here, Prem, they will cause rainfall in the eastern part of the Aravallis. Along with that, see, Punjab, Haryana till that point of time have not received rains. Those of you belonging from the region of Punjab and Haryana would also attest to the fact that by the time of end June, the temperature in Punjab is in the range of again 40 to 45 degrees Celsius. So there is that low pressure. Winds, they get attracted to that low pressure. They will cause rainfall here. As soon as that temperature cools down, more winds, the next batch of winds which come, they will get supplied to the region of the northwestern area. Okay, understood? Okay. Sapna, about your question. Why western side of Punjab does not receive rains? Okay. Again, I will have to make use of a map. So here, let's use this map itself. Now here, these winds, they come over, they cause rainfall, and basically the Arabian Sea branch of monsoon, it meets with the Bay of Bengal branch, will cause some rainfall, lower the temperature, move forward. Then what is their next stop? Some periodic rainfall in the region of Punjab, Haryana, here and there. Then they will hit the Himalayas. When they will hit the Himalayas, Uttarakhand, Himachal, eastern and northern Punjab, from the region around Pathankot, Gurdaspur, those areas, they will start receiving rainfall rather than your Kapurthala, Amritsar, because they are directly in the windward side of the mountains. That is where the foothills of the Himalayas will receive rains. Now, more winds get supplied. Now, we do know that when we talk about the Himalayan mountains, we do know that there are three ranges, isn't it? There are three ranges. Just a rough diagram here. Now, as these move over, they will bring rainfall across the foothills. All the regions of the foothills will be receiving continuous and heavy amount of rainfall, orographic rainfall. Some of these winds will transition over. Again, they will hit the middle Himalayas. They will cause substantial amount of rainfall in the valley region and also in the southern foothills of the middle Himalayas. Some winds will then transition over with lesser amount of moisture. They will cause rainfall here also. By this time, the winds have been drained of any moisture whatsoever. So by the time they reach the northern portion, the region around Ladakh, they are almost drained of all the moisture. That is when Ladakh generally receives very little amount of precipitation, and precipitation received is also for a very small or short duration. Okay, I hope that is understood. Now, there is another factor, and that is heating of the Tibetan highlands or the Tibetan plateau. Now, this Tibetan plateau plays an important role in strengthening the monsoon, not in the very functionality of the monsoon mechanism, but in strengthening the monsoon. How? So, here, when we talk about the Tibetan plateau, the Tibetan highlands, they are made up of basaltic, dark basaltic rocks, substantially dark basaltic rocks. They make up the region of the Tibetan plateau. Okay. Now, this Tibetan plateau basically will be significantly heated up during the summer. It will also get heated up because of the darker rocks. Albedo will be less, they will absorb more. Now, from this Tibetan plateau, there is that low pressure system which generates upper air winds. And those winds have the potential to strengthen the Indian monsoon. How? So basically, let us understand that. So Tibetan highlands are the highest plateau in the world and comprise of rocky structure. As a result of this, heat is gained and lost very quickly by these rocks. So over the Tibetan plateau during summer, very intense low pressure system is formed. Very intense low pressure system is formed. Okay. Now, how and what does it do? So, let us have a broader analysis. So, here, let's suppose you represent this as a surface. And here, let's suppose you consider this, even though it is not to scale map, it is not as per scale, but still, I hope you will understand. This is your Tibetan highland at an elevation of 5 kilometers. During the summer season, these Tibetan highlands have a temperature of around 15 to 20 degrees Celsius, due to which there is a very intense low pressure created. Let's suppose the temperature here is 15 degrees Celsius. That leads to creation of very intense low pressure. Now here you might have a question. 15 degrees Celsius is cold. Why are you saying it is intense low pressure, very intense low pressure? 15 degrees Celsius is supposed to be very cool, pleasant. People go to the hill station to celebrate. And here you are saying very intense low pressure. Why is that? Very good. Basically, because of the altitude. 15 degrees Celsius at an altitude of 5 kilometers. Let's assume the temperature here is, let's assume 35 degrees Celsius. With a lapse rate, during the summer season, if the lapse rate is considered to be 10 degrees Celsius per kilometer, at an elevation of 5 kilometers, What is the temperature that we are staring at? What will be the temperature at an elevation of 5 kilometers? If the ground temperature is 35 degrees Celsius and the lapse rate is 10 degrees Celsius per kilometer, what is going to be? Very good. 85. Okay. Lapse rate is 10 degrees Celsius per kilometer. Ground temperature is 35 degrees Celsius. Temperature at 5 kilometers will be minus 15. Okay. So the genius is in maths. So here, basically, it will be minus 15. So the temperature at 5, again, someone is with 85. So the temperature here will be minus 15. Over the Indian subcontinent, the temperature is minus 15. But over Tibet, at this point of time, you have 15. So a difference of 30 degrees Celsius. So imagine the intensity of the low pressure. It will be very, very intense. And with that intensity, it will lead to the rise of the winds and a violent rise of the winds. When you have such substantial low pressure, you will have that powerful vertical rise of the winds. These winds, they will rise up. Now, this is already at an elevation of 5 kilometers. So can we say that these winds will hit the tropopause almost immediately? We can say that these will hit the region of the tropopause almost immediately, right? So when they hit the tropopause, then what happens? Here the wind is getting risen up from one particular small area. So after they hit the tropopause, they will diverge. They will diverge in all directions. Isn't it? One of these portions, if I show it on the map, if I show on this map, I'm showing about upper, because I know I will have many questions regarding this, and I'll tell you the question also what it will be. But before that, let me again specify right now what the wind direction I'm indicating is the upper air movement. After the wind has hit the tropopause, then what will happen? Okay, then it will diverge. So here, let's suppose it hits the tropopause here. Then the winds will diverge in all directions. One such upper air movement will then bend to the left, bend to the right. And then overall, this upper air movement from here, it bends to the right. It is the upper air movement, guys. Again, it is the upper air movement. It will move through the Kolkata-Hyderabad axis. It comes over, crosses the equator, bends to the left, and there's a high pressure zone where there's a sinking air already. Where is that sinking air in this vicinity? In this vicinity, you have the mascarene high pressure, where you already have the sinking air. So there, all these winds will find a destination. They will come to the mascarene high. So here, these winds, they come over, they cross over to from the Indian subcontinent. They cross over the equator. Let's suppose this is the equator. Then, in the region of a high pressure where you have a sinking air, That is where they will sink in the region of mascarene high pressure. Near Mascarene Islands. Now, here you might have a question. You will have a couple of questions here. But the first question that you might have is, why is it that it will sink only in Mascarene Islands? Is there a prior deal or an agreement like that? Why is it? Is this some kind of a nepotism or red tapeism kind of a thing that only in Mascarene High? No. In the region of Mascarene High, already the air is sinking. So there's a vacancy created in the upper region, so that will also be sinking. Eventually, all of that will hit the ground surface. Now, this sinking of air around the region of Mascarene High, will it strengthen the high pressure? Will it cause no difference? Or will it weaken the high pressure? What do you think? Ketan, my dear friend, did you attend yesterday's session or the session on Saturday? We have the attendance records also, but I would like to know it from you. Yeah. So, my dear friend, that is why you are facing it incredibly difficult to follow. I would again urge you, take a look at the recordings and then you will be able to understand, because you have missed many portions about jet streams, about the entire aspect of movement. You might have missed that. So that is why you are facing difficulty. Yesterday we had talked about the Mascarene Islands and the Mascarene high pressure. Do attend the portions of the recordings. Okay. So here they will weaken the high pressure. Okay. They will strengthen the high pressure. These sinking winds, they will strengthen the high pressure. Okay. Why? Because sinking air will always strengthen the high pressure. So if the Mascarene Islands high pressure becomes stronger, can we say there will be more winds driven here on the surface towards Indian subcontinent? Yes, Ankush, that is the explanation. More winds will come here, they will rise up. It will cause daily occurrence of rains. Understandable? So can I say, now let me form the interlinkage. Heating of Tibetan highland has led to that rise of air. That rise of air has basically led to the divergence eventually and the upper air movement. This upper air movement will eventually strengthen the Mascarene high pressure. Strengthening of Mascarene high pressure will drive more winds towards the Indian subcontinent, isn't it? Now, can we say that heating of Tibetan highlands will further strengthen the Indian monsoon? And if the Tibetan highlands don't get heated up enough, you won't have this upper air movement at all. That means the monsoon will remain as it is without much influence, the normal monsoon. But if in certain years the Tibetan highlands get superbly heated up, there will be this upper air movement, and that will lead to occurrence of rains also. Fair enough? Understandable? Any doubts? Good. This upper air movement of wind, it happens at a speed of around 100 km per hour. It is temporary. And this is what is known as the tropical easterly jet. Why easterly here? Why the name tropical easterly? Because look at this movement in upper air. Upper air circulation. So it is almost from east to west. Kolkata Hyderabad axis, that wind is very apparent over the Kolkata Hyderabad axis. That is why wherever you will, if at all you will go deeper into the portion of the tropical easterly jet, you will always find that this moves from the region of the Kolkata Hyderabad axis. Now, here, this tropical easterly jet eventually will strengthen the mascarene high pressure. The mascarene high pressure. So, this mascarene high pressure is actually the driver of winds towards the Indian subcontinent on the surface. So, more of this upper air movement means more surface movement of winds will happen. These are your surface winds. So, more upper air movement will have more generation of these surface winds from the region of mascarene high pressure, and they will continue to provide rains. So here, during the summer months, the rocks in the Tibetan highlands, they become very hot. That is basically the rocks are predominantly, see, even these factors which you don't pay much attention to in your day-to-day lives, that what kind of rocks are there, how will it influence the climate? It is predominantly the basaltic rocks. Basaltic rocks are darker in appearance. Darker in appearance means that they will absorb more heat. Absorb more heat means low pressure systems. If it would have been typically granitic rocks, lighter in appearance, or felsic rocks, lighter in appearance, it would not have gained enough sustained temperature. Right? So these, or that is why climate is basically, it is the good thing about climatology is nothing happens randomly. Nothing will happen randomly. Everything follows a logic. If there is occurrence of rainfall in your area, there would be a low pressure which has attracted the winds in your area. If there is a dry condition in your area for a long period of time, that means that there is a very competing or a very strong low pressure somewhere else where all the winds are going to. Despite having that windy environment, you might not experience cloud formation or occurrence of rainfall. Right? Sometimes you would have observed that there is cloud formation. For the previous 2 to 3 days, there has been so much heating, there is cloud formation. But winds have started coming in, all the clouds, they maybe for 5-10 minutes, they will cause rain, all the clouds have moved. Why? Because maybe 100 kilometers from your area or 200 kilometers from your area, there would have been much substantial low pressure, which would have immediately attracted the winds. So if you apply logic, everything has got an answer in climatology. 2 plus 2 makes 4. As simple as that. But you need to understand that whether it is 1 plus 1 plus 1 plus 1 is equal to 4 or 3 plus 1. So how many factors are involved in getting that outcome? That is something that you need to grasp over. Okay? Primarily monsoons, the end result is that heating of land will cause rainfall. But observe how many different factors are involved in strengthening or weakening the monsoon. Okay, so that is basically the aspect. So rocks are predominantly basaltic with low albedo. over albedo. Now, they form intense low pressure region over Tibet. Resultantly, the air rises up and diverges from a height. The divergent air goes all the way to the southern hemisphere and sinks over the region of Mascarene High. This upper air movement is sometimes referred to as the tropical easterly jet. This tropical easterly jet forms an important cycle to strengthen the monsoon. In certain years, during the month of December and January, sometimes even up till February, the region of Tibet receives such heavy amount of snowfall, such significantly heavy amount of snowfall is received that the melting does not happen sufficiently till June. It continues to prevail, it does not melt significantly. So that is when you will observe that the monsoons, they are, or the tropical easterly jet is not generated because the heating has not happened. Sometimes what will happen that snow melt is completed by the month of May, and from June onwards the heating begins of the Tibetan highland. But sometimes even by the month of June, if you have some ice cover, ice will have higher albedo, higher reflective quotient. So heating won't be that permanent. Okay. And Sushmit, I figured our Y leeward side leftward tilt because land heats up more and low pressure formed is stronger. Yes. Simple terms, Sushmit, it is because of the low pressure that the winds will get attracted. Wherever they will get the low pressure, they will get attracted. And the winds, anyways, they move over from water bodies to land area because of that ITC set. That is why the winds they tend to cross over. Remember the first logic. Land is low pressure, water is high pressure, so there's a comparative pressure gradient which will bring the winds. Anyways, Ankush, the only the component that's coming towards Indian subcontinent from Tibetan plateau, that's called the subtropical easterly jet. Yes, only that component. The other components, they are not named. No. Prem Kumar, is there any possibility to alter Indian monsoon through man-made activities like artificial rains? Basically, what happens is that due to deforestation, etc., the occurrence and the persistence of low pressure, the supply of moisture from the ground, that gets altered. So the rainfall distribution gets altered. So that is the anthropogenic disturbance to the monsoon, where due to this continuous deforestation activities, etc., that is where the rainfall pattern gets disturbed. Githyon, that we will come to. Don't worry. As Purvaya are blowing, will they not affect the tropical easterly jet? Those winds are the Purvaya or the easterly winds from Bay of Bengal. These are the surface winds. Tropical easterly jet is at an upper elevation, not that strong as compared to the normal subtropical westerly jet, etc., which won't allow any air movement underneath them. So these are the case of weaker winds, upper air circulation. They are just named as a jet stream because of upper air circulation. They don't possess. Tropical easterly jet is not like your typical polar jet or the subtropical westerly jet, that they are present over such a large area that they have their own individual identity. This is just a kind of a local circulation in the upper mid atmospheric level. That is why they are named as a jet. Okay. I had a confusion why winds move from Tibetan highlands. Tibetan highlands to Mascarene High. The winds will move. See, Tibetan highlands will, again, this is the reason that I have listed out here. Basically, there is an intense low pressure formed over the region of Tibet. As there is intense low pressure, the winds will rise up over Tibet. They will then diverge. They will move in all directions. One of those portions will move over the Indian subcontinent, cross over the region of equator. In the region of Mascarene high pressure, you already have a sinking air. The air is continuously sinking, so there's a vacancy in the upper atmosphere. So as this tropical easterly jet is coming, there is a vacancy, so they will start filling that vacancy. They will start coming towards that region of masculine high, increasing the high pressure. Despite the sinking wind strength, the high pressure, how wind moves to a high pressure masculine island in the first place? Monisha, I hope by this answer that I have given you, you would also have understood. Is the wind that comes from masculine islands called surface? That is the surface wind ram. Yes. Now we come to the factor of the masculine high, but do we take a break before that? Okay, fair enough. We take a break, and after that we come and we talk about the aspect of masculine high, then Enzo and IoT. Okay, so let's take a break. We'll be back by around 7. Yes, Ankush, that will be correct. A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm. Thank you. So now we come to the next major influence, and that is the Mascarene High. Now, Mascarene High, basically in the region around the Mascarene Islands, in the subtropics of the southern hemisphere, that is where the subtropical high pressure zone develops. So this is the zone of the subtropical high pressure. Subtropical high pressure develops. Now, this high pressure is the driver of the winds. Winds to the ITCZ. During summer, monsoons season, winds from high pressure reach the Indian subcontinent where the high pressure exists. Okay. Now, during the monsoon season, the winds reach the Indian subcontinent. This basically also means that strength of high pressure or strength of Indian monsoon is directly proportional to the strength of high pressure. So, stronger that the high pressure is, more winds are going to be driven towards the Indian subcontinent. If the high pressure gets weakened, you will have lesser amount of winds getting driven towards the Indian subcontinent. So that is a kind of a direct relationship which is established. Okay. Now, then here, this is a zone of high pressure which exists around the Mascarene Islands in southern hemisphere, and hence the region is referred to as Mascarene High. During the monsoon months, when it is winter in the southern hemisphere, this region of high pressure is the source of winds which travel across the Indian Ocean to reach the ITCZ, which at that point of time lies over India. Stronger the high pressure, more is the rainfall received in India during the monsoon season. Clear? Now, after this, wherever or whichever factors that we look into, here we can always analyze it with the impact that it creates on the Mascarene high pressure. So first of all, the impact of El Nino and La Nina. So when we talk about El Nino and La Nina, or the Enzo cycles, these are the factors of climatic conditions which influence the region of Pacific. Okay, the factors which influence the conditions in Pacific, but they will have, earlier also we have seen that they have their arms or they have their circulation which carries on even in the portion of the Indian Ocean. So basically, during the time of El Nino or La Nina, these end up impacting the strength of the Mascarene high. So the circulation induced by the Enzo cycles, they will impact the strength of the Mascarene high pressure because of their circulations carried out even in the Indian Ocean. So these will circulations generated over the Pacific will impact the mascarene high pressure. How? So, basically, conditions of El Nino decreases the overall rains received in India during the monsoon months. Conditions of La Nina leads to a surplus amount of rains during the monsoon months. Even this much amount of information, if you carry along with you, that is also going to be sufficient and relevant enough for your examination perspective, at least for GS. But the why and the how of it is always important. So understand this. During the La Nina conditions, what do you observe? Here, in the region of Pacific, Central and Eastern Pacific, you have a high pressure. You have a low pressure over the region of the Western Equatorial, South Equatorial, or around Equatorial Pacific. Then after that, observe here, the air rises up, it diverges, and then here there is a sinking column. Now, what will this lead to as an impact over the mascarene high pressure? Will this strengthen the mascarene high? Will this weaken the mascarene high? Let me know. Very good. Godavari, Sakshi, Khushi, Vikram, Dikshit, Prerna, Brajneet, Yasir, Sapna, Anushka, Anjan, Krishika. Good. Very good. In a way, it is going to strengthen the mascarene high. The mascarene high, when that gets stronger, it will be the driver of the winds. So it will drive more winds towards the Indian subcontinent, isn't it? So due to heating of the Western Pacific, that is the impact of La Nina, due to heating of the Western Pacific, there's creation of low pressure over the region, Western Pacific. In the Western Pacific, the air rises up, forms clouds, and after that diverges from the region of tropopause in the eastern and the western directions. The part which moves to the west towards the Indian Ocean eventually subsides in the region of mascarene high, thereby strengthening the mascarene high pressure. If the mascarene high pressure becomes stronger, what will we have? More monsoon winds being driven towards the Indian subcontinent. More amount of winds being driven towards the Indian subcontinent, increasing the amount of rains received in India. So that is why La Nina is always associated with increased rains in India. Is that understood? Increased rains in India. Now observe the circulation during El Nino. During El Nino, you have the rising air parcel in the region of Central and Eastern Pacific. That is where you have the rising air parcel, right? Then the air diverges. Basically, after that, the air sinks here. A high pressure is created here. And then the air will diverge from this region. It will rise again from this area. So what will be the impact on mascarene high? If you have air rising from this area, what will be the impact on mascarene high? Very good. Mascarene high will become weaker. So when the mascarene high pressure becomes weaker, lesser winds, lesser amount or quantity of winds will be driven towards the Indian subcontinent. So due to the heating of Eastern Pacific, there is creation of low pressure over the region. The air rises up, forms clouds, and after that, diverges from the region of tropopause in the eastern and western direction. The part which moves to the west induces a circulation which eventually will weaken the high pressure system in the existence of a region of mascarene high. This weakens the intensity of monsoons, and hence El Nino is associated reduced rains in India. See, the meaning, Ketan, the meaning of mascarene, you don't have to go into the meaning. What is this mascarene high? It is the high pressure formed around the mascarene islands. Where are the mascarene islands? Mascarene islands are to the east of Madagascar, where you have a subtropical high pressure which is developing. Right, subtropical high pressure zones develop. You have seen that in the atmospheric circulation in the case of permanent wind system, that you have various high pressure low pressure zones develop rather than a belt. So this is the subtropical high pressure zone. Now from here the winds will be supplied. The winds ideally will be trying to move towards the region of the ITCZ. So stronger the high pressure means more winds would be supplied. More winds as they come over, they cross over. They would have crossed over that entirety of the water body, and they would be more moisture laden, and they will cause sufficient and substantial amount of rains along the way. Okay. So please do look into the region of do look into the portion of the atlas. Do look into the region to the east of Madagascar. You will find the Reunion Islands area. There you will find Mascarene Islands also. Akash, where is it, Akash, that there is a typo? Reach the Indian subcontinent. Is it here? Okay, yes, that is true. Thanks, Akash. Where the ITCZ exists. Fair enough now? Thank you. So now, moving ahead to the impact of, so Ketan, is that understood now? What are we talking about? Mascarene high. Mascarene high we are talking about continuously. What is that mascarene high that we have talked about? I hope that is clear now. It is the high pressure region around the Mascarene Islands. That is what is known as mascarene high. Okay, it is not some complicated word. It is not like that. Mascarene high are dry throughout the year. No, even this high pressure system, that tends to shift from one region to another. But generally, when you talk about the tropical islands from time to time, they keep on receiving that convectional rainfall. But during these winter months, during the period of the monsoons, when we receive monsoons in India, so that is when Mascarene region or the Mascarene Island region does not receive much rainfall. Okay. Now, coming to the impact of the Indian Ocean dipole. Now, here, let us understand this. Till now, if you have understood the portion of the mascarene high pressure and everything, I don't think you should have any difficulty at all. So, first of all, itself, let us draw the region of the mascarene high pressure. This is the driver of the winds. Okay. Now, basically, here you have the wind systems which are generated from here. Their destination is the low pressure in the ITCZ. In the middle portion also there are multiple different low pressures which will attract them, but their ultimate destination is the ITCZ. Let's suppose the ITCZ exists somewhere here. Excuse me. Now, IOD has got three phases: neutral, negative, and positive. During neutral, Where is the low pressure in existence? In the Eastern Indian Ocean or the Western Indian Ocean? During the neutral phase, where will you have the low pressure? Very good. Around the region of Indonesia, eastern portion of Indian Ocean. Now, if you have a low pressure here, low pressure condition here. So, the winds don't know what is India, what is Indonesia. Winds know only high pressure, low pressure. Will I be correct to assume that because of this low pressure, some of the winds from here, they will get diverted towards that low pressure? Fair enough. Some of the winds will get diverted to that low pressure. Now, when the winds they would get diverted to that low pressure, means what? Now there is lesser amount of winds reaching India. So lesser amount of winds reaching India means this is a kind of a competing low pressure to the ITCZ. It is competing with the ITCZ. It is diverting the winds from the mascarene high. Lesser amount of winds reaching Indian subcontinent means lesser moisture reaching Indian subcontinent. Means now there will be lesser rainfall in India. Is that making sense? Again, in the case of a neutral IOD, you have low pressure system which is formed over the region around to the west of Indonesia, in the region of the Eastern Indian Ocean. So that is where you have a low pressure. This low pressure will start diverting winds from the mascarene high, means lesser amount of winds will reach India. Much of that wind will be diverted. So when you have lesser amount of winds reaching India, means lesser rainfall. So neutral IOD is associated with reduced rains in India. Fair enough? Now, after this, let's suppose when we say negative IOD, negative IOD observes a low pressure region where? Eastern Indian Ocean or Western Indian Ocean? Very good. Eastern Indian Ocean. Now, during the negative IOD, we know that the intensity of low pressure will be much stronger than the neutral condition. So during that negative IOD, this low pressure will be much more intense. Can we have a scenario where now more winds will be diverted towards this competing low pressure? More winds will be driven towards this competing low pressure. Means what? There will be lesser amount of winds being driven towards India now. Which means what? Significant scarcity of rainfall when it comes to Indian subcontinent. Isn't it? So the normal process that you have seen during the neutral conditions of IOD that you have seen, that will get significantly exaggerated. So in the negative phase, significantly amount or significant reduction in the amount of rainfall. So let's suppose there's a La Nina condition. La Nina condition will strengthen the mascarene high pressure. We have seen just now. But simultaneously, there's a negative IOD. So regardless of how strong that you make the mascarene high pressure, if there's that competing low pressure, it will attract all the winds. So then, what do you have? You have lesser amount of winds reaching Indian subcontinent, isn't it? So that is basically where La Nina condition basically counteracts, or negative IOD can counteract the impact of La Nina. Now, let us consider the other case when you have a positive IOD. Let us consider the case where normally from this high pressure under the general conditions, winds are directed towards the Indian subcontinent. Now, the positive IOD. Positive IOD is associated with the creation of low pressure in the region of Arabian Peninsula, the Arabian Sea, and the portion of Somalia. That is where you have the positive IOD creating a low pressure. This will be the low pressure. Now, if you think about it, this low pressure is in the same pathway where the winds are blowing. It is not as if the winds have to move somewhere else. The winds have to divert their pathway. That is not the case. Winds will continue to move in the same pathway and then they can reach the region of the low pressure. Fair enough. Now, here, this low pressure, in a way, will start attracting more winds from the mascarene high. So, as they start attracting more winds from the region of mascarene high pressure, more winds will cross over the equator and reach here. It will cause occurrence of rainfall in this area. Sometimes this low pressure can even lead to the development of cyclones in the Arabian Sea. But now, can I say that here now you have more supply of wind movement as compared to the other or the natural conditions or the normal conditions? Can I say that now you have much more supply of winds here because that positive IOD has managed to attract all the more amount of winds from the mascarene high pressure as much as it can? Now, thereby, all these excess winds, surplus winds, they know absolute low pressure. What is the absolute and the greatest amount of low pressure at this point of time? The ITC set. Their ultimate destination is the ITC set. Right? So that is when these winds eventually will transition over. So what will be the impact on rainfall? They will cause an increase in the amount of rainfall. So the positive Indian Ocean dipole is associated with the increase in the amount of rainfall. Why? Because this low pressure which is created over the region of the Arabian Peninsula, over the region of the Arabian Sea, the Horn of Africa, this is not a competing low pressure. The low pressure created due to the negative and the neutral IOD, they were competing low pressure. They were competing with the ITC set. They were diverting the wind somewhere. This positive IOD is in the same pathway of the winds. So it is not competing low pressure. It is a supporting low pressure. It supports these winds to transition from that area, to move through that region. And thereby, these winds, they move through this area and then they cause rainfall. So that is why positive IOD is associated with higher than average rains. Rainfall over India. Okay, higher amount of rainfall received over India. So that is the case of positive Indian Ocean dipole. Now here, during the case of the positive Indian Ocean dipole, there will be more formation of tropical cyclones in the region of Arabian Sea. During neutral and negative phases, there will be more tropical cyclones formed in the region of Bay of Bengal. Now, let's suppose you have an El Nino condition. El Nino condition means the mascarene high will be weakened. it will be weaker in comparison. Now, at that point of time, if this is the supportive low pressure or a positive IOD is created, whatever that high pressure is, it will attract more winds from there, right? So, as a consequence of that, you might receive less than average rainfall, but it won't be a drastic reduction. It will be offset, it will be counteracted. That is why IOD phenomena tends to counter influence the impact created by the ENSO circulations. Now, after this, we come to the entire mechanism one by one. Yes, positive IOD is also possible with the occurrence of La Nina. So that is when India receives around 105 to 110% of the average annual rains. Now here, we come to the entire mechanism. So the first things first, the heating of the landmass means there is a transition of the ITCZ. The ITCZ by the month of by the month of June and July moves over the northern portion of the Indian subcontinent. This keeps on attracting winds from the southern subtropical high pressure belt, and this wind gets bifurcated into two parts, the Arabian Sea branch and the Bay of Bengal branch. Their destination is the ITCZ. Now, these winds, even though they reach the coastline, they reach the shore, they don't cause rainfall because still you have the presence of the southern branch of the subtropical westerly jet stream. The subtropical westerly jet stream, which has got a distinct northern branch and a southern branch, you still have the presence of that. Slowly and steadily, this southern branch continues to weaken. This southern branch continues to weaken. Eventually, this southern branch will end up disappearing. When this southern branch eventually disappears, that is when all these winds, they will be hitting the Indian coastline with all their might. Kerala coastline will first of all receive excess amount of rainfall. That is when it is declared that the onset of monsoon has happened. Just to fill you in with slightly more greater detail, I hope it doesn't confuse you. You know, when there is this disappearance of this jet stream, I gave you the traffic signal analogy. There is a rapid movement in upper troposphere also, in middle troposphere also, in lower troposphere also. So you know what happens at that point of time. Let's suppose this is the surface. You have massive wind movement happening at various heights, all of them moist winds. Now, near the ground surface, the air will rise up. That will lead to substantial cumulonimbus cloud formation. Here also there will be convection. In the upper air also, the winds, they will rise up. Convection will happen because of sudden movement. This cumulonimbus cloud so significantly develops. Many of the times these cloud types, they reach the level of tropopause. And that would mean continuous rainfall for a duration of 2 to 3 days. Very heavy rains. In the initial part of the monsoon, you would also have experienced that it rains very heavily for 2 to 3 days. You might have, it is not as if it is every second it will rain, but let's suppose but you have an interval of 1 hour or 2 hour where it is not raining, but it will rain continuously. The streets get flooded, everything happens. So that sudden pouring of rain, sudden and continuous pouring of rain for 2 to 3 days after the onset, that is also what is known as the burst of monsoon. Burst of monsoon. When you have convection at surface and upper levels creating rains. continued rains for 2 to 3 days after onset. That is the burst of monsoon. Okay, that happens after the sudden disappearance of the southern branch of the subtropical westerly jet stream. Now, the tropical easterly jet that gets generated in the month of late June and July, where you have the air rising up from the Tibetan highlands. This air diverges in all different directions. This air diverges in all different directions. One of this moves in a direction of east to west. It crosses the equator, moves to the region of the mascarene high pressure, where it eventually sinks. That is where it strengthens the high pressure. The high pressure, when it gets stronger, it drives more surface winds towards the Indian subcontinent. And that is what will increase the amount of rain. So, the tropical easterly jet or the heating of the Tibetan highland, it is not a main driver of the Indian monsoon. It is just a strengthening factor for the Indian monsoon. It is not the main driver of Indian monsoon. It is a strengthening factor which makes the monsoon stronger. Then we have seen already that the impact of El Nino, La Nina, El Nino reduces the amount of rainfall, La Nina increases the amount of rainfall. Indian Ocean dipole also we have seen positive IOD is associated with higher than average rains, negative and neutral IOD is associated with lesser amount of rains received in India. We have taken a look at this. Okay. We have also seen the case of Madden-Julian oscillation. We have seen the case where Madden-Julian oscillation cycles, if they are of a shorter time duration, they will lead to much frequent rains during the monsoon. And if it takes a longer period of time for that Madden-Julian oscillation to come back to the Indian Ocean, it will take a longer time gap for India to experience rain. Okay? Those of you who would have appeared for the prelims test series, you would have got many questions from this area in case you have appeared for the prelims test series. Can you show the slide where you wrote the burst of monsoon? This is the burst of monsoon. So now do you know about how the rainfall progresses and advances over the rest of the country also? So the monsoon, its impact begins in the south and the east. Slowly it moves to the north and the west. So the northwestern portion of India is the last portion which receives rainfall due to the monsoon. Then the retreat of the monsoon. What do we refer to as the process of retreat? Retreat, in simplest of the terms, in terms of interpretation, means what? Something which starts returning back. That is the retreat. Withdrawal, right? The withdrawal of the monsoon system. What is this monsoon system? Moist winds coming over to the Indian subcontinent bringing rainfall. So we are eventually looking at the withdrawal of this moist wind system, isn't it? That withdrawal of that moist wind system that is causing that retreat. So this is where the entire low pressure system created by the ITCZ, where the winds are coming in, that ITCZ starts withdrawing from India. Why? By the time of around mid-September, the sun would have reached the region around equator. And from September onwards, 23rd September onwards, the southern march of the sun begins, where the sun now starts shining almost vertically over the southern hemisphere. So when that southern march of that sun begins, the ITCZ starts withdrawing from the Indian subcontinent. As the ITCZ starts withdrawing, it generally is initiated after around 17th of September. It takes around 1 or 2 months for that entire system of ITCZ to completely withdraw from India. So here you have the ITCZ from around 17th of September onwards. This will be the ITCZ. Then it will come here. In the month of October, it will come here. November, it will come here. December, it will come here. Mid-December, here. So, can I say that from mid-October onwards, mid-October till December, can I say that there is a pre-existing low-pressure condition over Arabian Sea and Bay of Bengal? Can we come to a conclusion that with the withdrawal of the ITCZ, again you have a pre-existing low-pressure system over Arabian Sea and Bay of Bengal? Now, when you have that pre-existing low-pressure system, what atmospheric phenomena is resulted due to that? Very good. A tropical cyclone. This is the reason why, even during the months of November and December, you will experience the formation of tropical cyclones in the region of Bay of Bengal and sometimes even in the region of Arabian Sea. Okay? But the difference between the tropical cyclones in these conditions is the fact that, let's suppose you consider the tropical cyclones developed in the month of March or in the month of May and June. In the month of May and June, if there is a low pressure or heating of the water body creating a cyclonic system here, this wind system during the month of June, they will try to reach the ITCZ. So they will push the tropical cyclone towards this ITCZ. The tropical cyclone will move, will recurve, will hit West Bengal and will hit the region of Bangladesh. Okay? Sometimes it might even, let's suppose it is formed here, it might even hit Odisha. But then, during the month of November and December, you don't expect the tropical cyclones to hit Bangladesh. Why? Because then the ITCZ, let's suppose, is here. ITCZ previously, let's suppose, was here. It has transitioned south. Now here, the tropical cyclone is getting created. Now the trade winds will push the cyclone towards the region of ITCZ. The trade winds, basically, they tend to move towards ITCZ. Here, the cyclone will bend slightly to the right. They will hit what? Tamil Nadu coastline. That is why the tropical cyclones formed during November and December predominantly will hit the southern part of the country. The tropical cyclones formed during May and June will predominantly end up hitting the northern coastline of the country. That is Gujarat, Maharashtra on the western side, West Bengal, Bangladesh on the other side. Okay? I hope that is understood and grasped. So, this entire process of that withdrawal of the ITCZ basically means what? The moist winds which were being carried over, they will reach here in this area. So we can say that the monsoon winds have retreated. They have withdrawn It has not happened overnight. Earlier, when the ITCZ was here, the monsoon winds would reach here, or the monsoon trough, wherever it was, the monsoon winds would reach here. When it was here, ITCZ transitioned here, the monsoon winds would reach here. Slowly and steadily, there is a withdrawal. So that is the process of retreat. Now, over the Indian subcontinent, there will be a wind system which will be established. This is ITCZ. ITCZ is basically the attractor of the winds from both the tropics. So during the month of November, late October, November, December, as it is withdrawing, you will again find the presence of northern trade winds over the Indian subcontinent. Now, these trade winds, will they carry moisture? What do you think? Will these trade winds carry moisture? No. They are coming from land areas, so they will not cause rainfall. But what about the trade winds which come from here? They will cross Bay of Bengal, where they would have picked up moisture, and then they hit the Tamil Nadu coastline or Coromandel coastline. So, the eastern coastline of India, the Coromandel coastline of India, receives rainfall during these months, October, November, when you have the withdrawal of the monsoon. So, this is withdrawal of monsoons, monsoonal winds is generally initiated after 17th of December or 17th September, takes around 1 to 2 months for complete withdrawal. Direction of winds. What is the direction of winds over the Indian subcontinent during this? Direction of winds is northeast to southwest. Direction of winds, is from northeast to southwest. Rains will be received where? Coromandel coastline. Okay. So if you observe this process of retreat, observe here. First of all, the monsoon begins its retreat from the northwestern part of India. So we can say that the monsoon system reaches the northwestern part the last, withdraws from there the first. So the region which experiences the monsoon phenomena for the shortest duration is the region around Punjab, Haryana, the western part of India, northwestern part of India, experiences the monsoon condition for the shortest duration. Now it starts withdrawing, observe on 1st of October. This is where it is, 15th of October, 1st of November, 15th of November, 1st of December. Generally, by mid-November, this year, for example, in 2023, by mid-November, the entire retreat had been completed. Sometimes it happens in mid-October itself. Rather, in 2023, it was completed by around 17th or 20th of October, the entire retreat was completed. Now, once the retreat has been completed, now, the ITCZ basically moves closer to the region of equator. Now here in the northwestern part of India, here in this particular region, in the portion of Pakistan and adjoining portions in India, you have the high altitude Potwar Plateau. Okay, you would have heard about the name. If not, do find out the Potwar Plateau. Now, this Potwar Plateau becomes very cold. It starts becoming very cold from October onwards itself. It starts becoming very cold. This becomes a small generator of that high pressure. Now we are talking about the month of October onwards. So here, first of all, the equator. By this point of time, the ITCZ has transitioned. Let's suppose we are talking when the ITCZ has transitioned here or is in this region roughly. Now, this Potwar Plateau becomes the driver of wind systems. The winds will diverge from here in all directions. This is an anticyclonic region. Winds will diverge, they will move, they will be bending to their right. Some winds will follow the foothills, rest of them will bend to the right. One portion will get trapped in the northeastern region also, so whatever amount of moisture it has, it will bring rains. Then this wind system will be established. This is your trade wind system. Again, which portion of India will receive rains during this time? Some portions in the northeast and the Coromandel coast. Now, what is the wind direction here? The wind direction is northwest, northeast to southwest. Now, you can argue that, but this isn't it the same that you were talking about in retreat of the monsoon? But understand, retreat of the monsoon is a process of withdrawal. That is the process of withdrawal of the monsoon system, the low pressure systems from India. Once that retreat is completed, then the trade wind systems, they set in quite prominently, driven from that high pressure of the Potwar Plateau. Okay, so that wind system is known as northeast monsoon. Many of the books you will find that northeast and the retreating monsoon are given as one and the same. But if you look at the Indian Meteorological Department's website, it is not my own conjuring and my own fantasy. Basically, wherever you do that adequate amount of research in the as per Indian Meteorological Department or as per various different sources, you'll find that after the retreat or the withdrawal process has been completed, then the permanent wind system established over India, driven from that high pressure center, that is known as the northeast monsoon. Why it is known as monsoon then? Because remember what is the name or what is the meaning of monsoon? Seasonal reversal of winds. During the advancing monsoon, what was the direction of wind motion? Southwest to northeast. Right now, what is the direction of wind motion? Northeast to southwest. A complete reversal has occurred. India is amongst the very few areas across the world which actually experiences this complete reversal of wind. In many of the areas, you have the wind direction like this. Then in other season, maybe the wind direction will get established like this or somewhere like this. In India, you have a complete reversal. That is why India is referred to be the home of the true monsoon phenomena. Okay, so is initiated after the process of withdrawal is completed. After that process of withdrawal has been completed. Now, as that process of withdrawal has been completed, eventually, what you have? You will observe trade winds set up over India, direction northeast to southwest, duration November, December, January, areas receiving rains of rains, some areas in northeast but predominantly Coromandel coast. The Coromandel coastline. Okay. Now, after this, we come to the factor or the phenomena, what is known as the break in the monsoon. So, you would you should ideally draw it from your own personal experiences. In your region also, you would have seen that after the onset of monsoon has happened, then maybe after a week or 10 days or 15 days of rainfall, you experience that, or 3 to 4 days of rainfall, you experience that there is lack of rainfall, a period of dry condition. For 7 days, 10 days, 15 days, no rainfall occurs, where you also start to wonder, why are they declaring on the news that this region is getting flooded, there is occurrence of monsoons, my region is not receiving rainfall at all. So such lack of rains during the monsoon phenomena, when the rainfall has basically not happened in the area for some duration, that is the break in the monsoon. Now, why does the break in monsoon happen? It happens because of two factors. One of the factor which we have already talked about, let's suppose here you have Indore, here you have the region of, let's suppose, Raipur. Now, in Indore, you have a substantial low pressure, a very active and a significant low pressure, right? Now, in this area, winds have come, they have caused rainfall, substantial amount of rainfall. So this has lowered the temperature. So that low pressure, that has got so much amount of rainfall, now it will get converted into a kind of a high pressure because of lower temperature. After 3 to 4 days of substantial rainfall, it has gotten a slightly higher pressure or a moderate pressure. Let's not mention high pressure, let's mention a normal pressure condition. Meanwhile, the region of Raipur, for example, that region of Raipur has not received rains for a very long period of time. So now by that point of time, due to heating, the temperature would have become very high. So Raipur becomes very hot. Very hot, high temperature or low pressure. So now what will happen? All these winds, they will migrate here. They will cause rainfall in this region. Now, the earlier area where the rainfall was happening, now that region won't receive rains. Now, Indore will experience dry conditions for the next 7, 10 days or 15 days till it gets heated up substantially to develop that low pressure. Let's suppose in the meanwhile, you have winds, cooler winds from Raipur blowing over to Indore, again moderating the temperature, not allowing the temperature to rise up to 42, 43 degrees Celsius. Cold advection in the local area occurs. That will again not allow the low pressure to get created. So as long as you don't have that low pressure, winds won't come. So when you have a kind of a competing low pressure form somewhere else, that there is a diversion of the winds. For example, in the region of the Western Ghats, when you have the formation of a very strong low pressure over the region of Gujarat, for example, the winds, rather than hitting the Western Ghats, they start moving towards the region of Gujarat. In a way, when the winds are moving to the region of Gujarat, they will be moving parallel to the Western Ghats. There's a break in monsoon. So after rainy periods, if rain fails to occur for 1 or more weeks, it is known as a break in monsoon. Dry spells are quite common during the rainy seasons because of let's suppose you don't have enough low pressure system, or rain bearing storms are not frequent along the ITCZ and over the west coast, associated with days when the winds blow parallel to the coast, because maybe somewhere else that low pressure system has been formed. Now, then you have the pre-monsoon showers. So before the monsoon or the onset of monsoon, it is not as if the entire country is very dry. You have localized convectional rainfall observed in the regions of Bengal, Assam, some parts of Odisha also, Kerala, Karnataka coastline, and some parts of Tamil Nadu also. So they are named differently in different areas. But overall, this is not a part of the monsoonal rainfall. It has occurred in the month of late April or May. That is why they are known as pre-monsoon showers. Not a part of the monsoon, but pre-monsoon showers. This is very helpful for certain crop varieties of rice. This is also helpful for varieties of jute, for example. Jute, which requires very heavy amount of rainfall. So it requires pre-monsoon showers also, monsoon showers also. Right? Now, here, this is known as the mango shower in the region of Karnataka and some portions of Kerala. Why? Because towards the end of summer, there are pre-monsoon showers. These are strong convectional rains. Very strong convectional rains. They are called mango showers as they help in the early ripening of mangoes. In the region of Bengal and Assam, what is observed is that these moist winds, they cause the formation, or they lead to the formation of cumulonimbus clouds, and there is heavy rains associated with thunder and lightning. And those heavy rains associated with thunder and lightning, they create stormy conditions, and that is what is known as Kal Baisakhi in the region of Bengal and Bardolisara in the region of Assam. So this is what is Kal Baisakhi and also known as Bardolisara in the region of Assam. These are useful for tea, jute, and rice cultivation. So whenever and wherever that rains occur, those rains are utilized for growth of crops. For example, we have seen that in the eastern coastline, Coromandel coast, rains will start happening from the month of generally October, November, December, January. Rice is planted during this time. That is why whenever you would have heard about the unfortunate news of Chennai getting flooded, you would hear mostly Chennai getting flooded in the months of November and December. Remaining portion of the country, you will hear about the news of the floods. When? In the region of Bihar, Assam, you will hear that Assam, first of all, you will hear the news of flooding earliest in the region of Assam, because the winds get trapped excess amount of rains in the month of late June, early July. By mid July, you will hear about the news of flooding in the region of the area of Bihar and the Himalayan region. And then in the month of September onwards, the central portion will experience that flooding. Godavari River Valley and the Godavari River, that is what starts flooding because the monsoon is withdrawing and is at that point of time present over central India. And then eventually it will migrate to the south. Okay. Now, we experience rains even during the month of November and December. Why? Delhi, Punjab, Haryana, Jammu Kashmir experiences snowfall, Himachal Pradesh experiences snowfall, Uttarakhand experiences snowfall, Sikkim, Arunachal. But rains occur in Punjab, Haryana, northern Rajasthan, New Delhi, western part of Uttar, even central and eastern parts of Uttar Pradesh, sometimes even Bihar, even the region of Bengal, and even Assam plains. Coromandel coastline during this time is understandable because of the northeastern monsoon. But why the rest of the portion, the northern portion of the country? It is because of a unique phenomena which we refer to as Western disturbance. But what is this Western disturbance? So understand it. During the winter months, the ITCZ has shifted to the south, immediately to the equator or to the south of equator. Now, even the subtropical high pressure belt will slightly shift to the south. Now, let us take a look at the region of the Mediterranean Sea. Now, winds from in the region of the European subcontinent, they will be colder during the winter. Mediterranean waters will be slightly warmer, isn't it? Can we expect the formation of a frontal depression here? A frontal low pressure system? Fair enough. And during these months, as the subtropical high pressure belt shifts to the south, you will have the predominance of westerlies. These westerlies, they carry the entire low pressure system along with the clouds, everything, the frontal depression because it is. They move over the region of Iraq, Iran, Afghanistan, Pakistan, and then they hit the Himalayas. The moment they hit the Himalayas, they will cause snowfall in the region of the Himalayas, from where cold winds will be driven towards the Indian plains, further worsening the winter or lowering the temperature, gripping the country in cold wave. Right? You would have heard about or read the news stories that there has been fresh snowfall in Jammu Kashmir, Himachal, Uttarakhand, and after 2 days, winters in UP, Delhi, Bihar, etc., the winters get much worse. Right? So in these areas, they will cause snowfall. Then in the Punjab Himalayas or in the region of Punjab, Haryana, Delhi, UP, sometimes northern Rajasthan, there also this low pressure system will travel, and that low pressure can cause rainfall because they are being carried by the westerlies. The westerlies are carrying them. That will cause rainfall all over. That will create rainfall all over. So this happens during the winter months. So again, let's suppose this low pressure has been transferred. Again, wind over Arabian or air over the Mediterranean Sea will still be warm. Air above Europe will still be very cold. Again, a front formation is there. As long as you will have that cold air over Europe, very cold air, this frontal formation will continue. So the period of the Western disturbance, the duration of Western disturbance, why it is known as Western disturbance? Coming from the Western direction. A low pressure system traveling from Western direction, hence the name Western disturbance. Duration and frequency, if you will observe. Then what? During the month of November, you will have 3 to 4 such occurrences. During the month of December and January, when these are at their peak, 6 to 7 such disturbances they hit. They not necessarily will only hit the region of Delhi, Punjab, Haryana, sometimes in Rajasthan also. And sometimes this low pressure, it can create such intense low pressure condition in the ground, it can cause hailstorms also. That is where a couple of years back, you had, due to these western disturbances, hailstorms caused in Delhi and some parts of Rajasthan. And immediately it became very popular on, I don't know which media channel picked it up. Snowfall in Delhi, a historic first, where India has now become the land of snow. It was not snowfall, it is only hailstorm. I hope by now you are able to understand the difference. By Feb, it becomes again 3 to 4. March, 2 to 3 such instances. However, this year, you know what? This year, this western disturbance was present even up till the month of July. That is where climate change is playing its role. That is where, when people say that climate change is no longer a thing of the distant future, climate change is in front of us today and now. The region of Europe continued to remain cold. And that is when, as it was colder, you had that frequent formation of these subtropical, extratropical storms. And in the month of July, monsoonal system which were established, one such disturbance, a couple of such disturbances, they came over and they collided with the monsoonal system. So imagine you have a low pressure system created by monsoon which is attracting moist winds. You have a low pressure system bringing moisture all the way from Mediterranean. When they will collide and mix, what do you expect? No rainfall, normal rainfall, or huge amount of rain? What do you think will be the expected course of action in that? Always, it will lead to very heavy, tremendously huge amount of rains. That happened in the month of July this year. Where? In the hills of Himachal Pradesh. That is when you would have heard about the news stories about all the landslides, etc., happening in Himachal Pradesh. It was not because of normal rains. It was because the monsoon rain somehow collided with the portion of the western disturbance. That is a historic first. But obviously, that never gets reported in the major media houses, because if the media channels they start talking about that western disturbance is colliding with the monsoonal system causing heavy rains, nobody will care, nobody will understand, and nobody will know what to follow. But if the same media channel will tell you Delhi has turned into Srinagar because of snowfall which has occurred for the first time, as you can see snow on the parks of Delhi, everybody will open up the news channel. So that is where this did not get reported that much. Indian Meteorological Department had held periodic conferences this year to alert the public about it, but for Himachal, it was already a bit too late. Now, then this is the western disturbances. So basically, these low pressure systems originate over the Mediterranean Sea and Western Asia and move into India along with the westerly flow, and hence are known as western disturbances. Presently, to the north of Tropic of Cancer, all the rains that are being received are because of the western disturbances. Some or the other impact created by western disturbances. They cause the much needed winter rains over the plains and snowfall in the mountains. Although the total amount of winter rainfall, the entire system in the local area around Haryana, Punjab, you refer to it as Mahavat. The rainfall is not very high in quantity, but it is beneficial for the early planting or the sowing of the crops such as mustard, wheat, etc. Rabi crops in general. So crops such as mustard, wheat, etc. Right. Some people talked about suddenly Shiva became angry. Yeah, I'm not going to comment on that. So basically, That is the theory which is floated due to whenever you have heavy rains in those areas. So, but because who will understand about Western disturbance? When you talk about Western disturbance, even here, if I give you an option, would you want to hear about Western disturbance or do you want to hear about BJP and Congress? I'm sure all of you will choose the second option. So that is the case with everybody out there in the wide world also. So here, this is the western cyclonic disturbance which forms over the region of Mediterranean. And as long as the cold northern winds or the cold winds from Siberian high, also driven from the region of Siberian high, as these winds come over, they mix, they will cause rainfall all the way till the region of Assam plains. Okay. Now the annual rainfall pattern in India, we can always say that the rainfall will reduce from south to north, will reduce from east to west. Why? Because you are moving away from the source of moisture, right? So amount of rainfall will be very high in the southern part of India, amount of rainfall will be very high in the eastern part of India. As you move to the north and to the west, amount of rainfall reduces. On the windward side of the Western Ghats, very heavy amount of rainfall. In the Purvanchal region, because of the funnel shape created by the mountains, very heavy rainfall. In otherwise, all the entirety of the country, average annual rainfall is somewhere around 120 centimeter per year. Okay. Now, let us take a look at few of the PYQs. Which of the following correctly describes the phenomena of Western disturbances? These are aggravated monsoon winds blowing from west to east. They originate over the Mediterranean Sea and are carried to India by winds. Their effect can be felt mostly during the months of July to September. They can bring rains only over the hilly tracts of Himachal Pradesh. This should be pretty simple. In 2023, first of all, the El Nino was not very strong, Anjan. And secondly, by the time that El Nino developed, you had a situation where the portion of northern part of the country, there it had an impact. The monsoon winds had an impact. But as far as the southern part of the country is concerned, the monsoonal troughs by the month of August and September had transitioned to the southern part. And along with that, there was a quick retreat of the Indian monsoon. This time, the withdrawal of Indian monsoon lasted for only 1 month. So, as it was quickly moving over the southern part, there was much occurrence of rainfall in the southern part. Rainfall in the northern part of the country this time was also impacted because of excessive rains and low pressure in the region of the Himalayan foothills. So, the rest of the north did not get much rains. And also, if you recall, in the month of June, there was formation of cyclonic storms over the region of Bay of Bengal and also over the region around the Arabian Sea. Now, this cyclonic rainfall, what it did, it lowered the temperature of the land. As the onset of monsoon happened, that temperature of the land mass in the north, which generally is around 40 to 45, that was hovering in the range of around 25 to 30, 32. So that substantial low pressure system, the monsoonal troughs, could not develop. So the trough developed in the region around the Himalayan foothills, the region around Punjab. That is where the rainfall went. And then in the south central portion, by the time the El Nino system was established. But this year, you are going to have a much stronger El Nino system. Okay. So here, majority of you have given the correct answer. The correct answer is B. They originate over the Mediterranean Sea and are carried over to India by the movement of the winds. Consider the following statements about the phenomena of El Nino and its effect on the Indian monsoon. So take a look at this question. It occurs in the region of South Pacific and hence has no impact on Indian monsoon. It leads to increased rainfall over the Indian subcontinent during the monsoon season. Its impact can be neutralized by IOD and MJO. Super cyclones, Ankush, are created when you have the cyclonic system drawing the winds with a speed of more than 220 km per hour. So there is a classification of cyclones even based upon the speed of the wind systems. So when you have the winds lower than 100 kilometer per hour or 80 kilometer per hour, it is not even referred to as a cyclone, it is a depression. When you have the wind speed in the range around 100 to 100 to 150 kilometer per hour, that is what is a cyclone. Then you have a kind of a strong cyclone system, very severe cyclonic system. Then you have the super cyclonic system, okay, based upon the wind speed. Now here majority of you have given the correct answer. The correct answer is 3 only. It occurs in the region of South Pacific and hence has no impact on Indian monsoon. Incorrect. It leads to increased rains over the Indian subcontinent during the monsoon season. Incorrect. Its impact can be neutralized by Indian Ocean dipole and the Madden-Julian oscillation. That is correct. Please, sir, you don't read the question. Okay, I won't read the question. Is that impacting your answering ability? I'll not read the question. You read the question. I will give you then how much time do you want? I'll give you 1 minute. Let me know. I think 30 seconds would suffice. Let's go for 30 seconds. Are western disturbances carried by jet streams? Vikalp, sometimes they are. Good. Vikram, why northeast monsoon can't continue beyond the month of January, sir, as northeast trade winds will blow in the same direction? Because that high pressure around the Potwar plateau, that starts weakening, and from the portion of March onwards, again the northward migration of the sun begins. So the ITCZ starts slightly moving. Very good. So here, Roshan, was this okay this time? So with reference to retreating monsoon, consider the following statements. The Coromandel coast receives heavy rainfall as a result of this. Correct. It generally spans over a long duration from September to November. That is correct. Movement of winds is from southeast to northwest. This is incorrect. Movement of winds is from which direction? Northeast to southwest. Okay. So here the third is incorrect. 1 and 2 are correct. So that is the correct answer. Okay. And okay, I have answered, I think, almost. Is this also impact of Western disturbance? Shruti, what is the impact of Western disturbance you're asking about? Kushi, why did Western disturbances occur in June this year? That was primarily because the Siberian high continued to provide the cold wind. So there was that frontal formation which continued to happen all the way. Even in the region of Mediterranean, there was frontal formation. So that continued to happen. And that is why you had the frontal formation being exaggerated into that low pressure system. And we have studied that ENZO. We have studied in ENZO that creation of high pressure over Madagascar during normal. That high pressure over Madagascar during normal and La Nina benefit monsoon, but same during Indian Ocean dipole, neutral and negative. Sushmit, your question is not very clear. We have studied in ENZO that creation of high pressure over is fair enough. But same during Indian Ocean. See, understand, during Indian Ocean dipole, you have low pressure either in the Eastern Indian Ocean or the Western Indian Ocean. When you have the low pressure in the Eastern Indian Ocean, in the region of Indonesia, that will start attracting the winds or driving away the winds from the region of the Mascarene High. So more winds won't be able to reach the Indian subcontinent. During the case of a positive IOD, you have the low pressure system created over Arabian Sea. That is where the predominant low pressure system is. So it is when we say IOD, it is not exactly from one end of the equator to the other end of the equator at Indian Ocean, roughly the eastern and the western edges of the Indian Ocean. So the Somali coastline on one side, Indonesian coastline on the other side. So that is why, if you are asking that during the negative and neutral IOD, you have high pressure in already present in the Western Indian Ocean. So why should not it benefit the Indian monsoon? Because all that high pressure will get the winds deviated towards the Eastern Indian Ocean. less winds will be driven towards India. Okay. Can we predict IOD for this year? No, IOD is basically carried out on a day-to-day mechanism. Abhishek, please explain first question, first number statement. These are aggravated western disturbances. Western disturbances are not monsoon winds. Monsoon winds are what? Which change their direction. In India, you have southwest to northeast and northeast to southwest. That is why that is incorrect. Okay. Now we come over to the case of climatic classification. Now, this is where, first of all, let me be very honest and very frank. This is going to be one of the tougher areas to digest for you. It is very theoretical. So I have included almost everything in the PPT itself, in the slide itself. You have the PPTs with you. Go through it. Today, we won't be proceeding ahead with this. This is going to be relevant only for your prelims examination. Only for your prelims examination, this is going to be relevant. For GS, in mains, UPSC doesn't ask Köppen's classification. In order to digest this, in order to understand this, there is a basic requirement where, as a candidate, you must be absolutely certain and absolutely sure about the permanent wind systems, in which direction do they move, shifting of pressure belts, what regions do they impact. That is something you have to be very sure in. So take today's time to go through this, browse through this climatic classification. I will tell you which areas are important. Tomorrow we will finish it and we will enter into the portion of oceanography. Okay. Today I will give you certain map points and then I will show you the leaderboard. I hope that is fine. So certain portions of mapping. Today we will go for the certain areas around the world map. First of all, here, Canary Islands, then Labrador Sea, Bay of Biscay, Falkland Islands, Kurile Islands. Kurile Islands is easier to find. Then North Sea, and the region of Iberian Peninsula, Lake Van in Turkey, Aral Sea, then Great Salt Lake, then Emperor Seamount System in the region of Hawaii, chain, and over the portion of India, Gulf of Kambat or Gulf of Cambay first, then Pork Strait, 10-degree channel, Then after that, you will also Amarkantak region, then Vindhyas and Satpura, everybody knows, located. Then after that, Dandakaranya, then after that, locate the area of Deccan Traps, Chota Nagpur Plateau, locate these portions in the map, and then we meet again tomorrow. Payal, we are looking into it, my dear friend, and we are trying to resolve this. Few of the other students are also facing this issue. We are trying to resolve it to the earliest. And hopefully, by the next month, this issue should be resolved. Ankush, periplanes basically are a resultant of a series of degradation which carries the materials, deposits them over a wider area. That is where you have almost a flattish surface created. Leaderboard, yes. Sorry, I forgot. So this is the leaderboard. Very good. Yes, Akash. So we'll meet again tomorrow. Till that point of time, take care of yourself. Goodbye. Thank you. Have a good night.